Alright, let's talk about magnets. Just a quick introduction. Is the Greeks near Magnesia, which is the reason why they're called magnets. Also, the early Chinese, they knew about rare stones um, that could attract iron. Probably they were iron that had been struck by lightning. And if you took a piece of iron and you touched or stroked, rubbed it on one of these fancy stones, it also became a magnet. And it was around 1000 that people in China found that the needle, if you could freely suspend it, it would point north-south. And I guess one way they did that is you would take a bowl of water, and if you put something that would very light that would float, like a leaf I've seen before, and then you put your needle, very thin piece of iron that's a magnet, it would be enough to spin this leaf and have it point in the proper direction. Um, Soon made its way to Europe. Christopher Columbus, it is said, used one when he crossed the Atlantic Ocean. They used to use the stars to find north, and he noticed that this needle was slightly different from the north, as the stars said, but and it also changed during the voyage, but it was going to be a good job for them, especially when the clouds are out. In around 1600, this guy Gilbert, he came up with an explanation. If a magnet wanted to point north-south, then the Earth must also be a giant magnet. And we'll talk about why that is in a moment. Let's talk about field lines. They were first introduced by a famous physicist who studied electricity and magnetism. His name was Faraday. He imagined a compass needle freely suspended in 3 dimensions near a magnet, and you could trace in space the lines one obtains when one follows the direction of the compass needle. So if I put a compass here, it would point up and down. If I put one here, it would point side to side. If I put one here, on an angle. And these lines that you could draw that show what direction the compass is pointing, they called them lines of force, or now we just call them field lines. You may have seen this. We can show them, and I would have showed you, I'd show you in class. If I use very small bits of iron, and I put them near a magnet, I get this pattern, and you can clearly see these lines of force. And to be clear, they're not just two-dimensional, which this picture shows you that some are pointing up and down and all around as these field lines come back to that magnet. So there's a nice 3D picture of what's happening. Magnetic field lines always start on the north and go to the south, and on the outside, and on the inside they go from the south to the north, only on the inside of the magnet. Yes. We know from magnets that opposite magnetic poles attract each other and similar repel. So why is the Earth a giant magnet? If this is the Earth, nice little Sheldon meme, the outer core moves around the inner core. So the center of the Earth is thought to be a solid because of the enormous pressure of gravity and everything squeezing in on it. It's a solid, and around it we've got a more fluid type material here, and as this fluid moves around this hard inner core, you get rubbing, almost like charging by friction, like when you rub a balloon on your head and then you get all staticky. You get a similar situation, and anytime you have charges moving, you get a magnetic field made, which we'll talk more about in the future, and that's why this thing becomes a big magnet. And the magnetic field lines start on the south and end at the north. Now I know that up here I wrote that if I have a magnet, they go from north to south. But let's think for a second. If I have a magnet and it's freely suspended, or a compass, yes, which way does the north on a compass point? It points north. So do you know what's up here then? A south. The geographic north pole of the Earth is actually very near the Earth's magnetic south pole. And this is too bad. There was a naming convention in place before people realized, and we weren't going back after. So what we call the North Pole magnetically is actually a South Pole. And that's why our magnets, all the north parts, because we know that opposites attract, so the north on my compass will point towards the south, and since it points north, north has got to be a south. Now that I've completely confused you, I'll keep going. So there are a few rules that govern these magnetic field lines. More force, more lines, and they're closer together. Yes, there's lines are concentrated near the poles. Lines go from the North Pole to the South Pole of a magnet, and lines do not cross. You'll never see these lines cross. So that's our brief introduction to magnets.